Hi Marcus, what are we going to talk about today?
I want to talk a bit about open science. If you want to understand what open science means, I think it's best to understand first how scientific knowledge is generated.
Okay.
So you usually first start with some kind of an observation. For example, you see that the number of snow days is decreasing. And then you want to find some evidence for that. So you start designing a study. You want to collect some data. You want to analyze the data, so you apply some statistics, for example. Of course, you have to know where you can find the data. You have to download the data. You have to find the right data. So if you want to know about the snow days, then you have to look for databases, for example, at different locations in the Netherlands, for example. And then you start collecting the data, you analyze it, and at some point you are going to interpret the results. And all of that you summarize in a report, and this is what we call a scientific article.
Yes.
And then you submit this article for peer review. So other experts from your area, so if it's about snow days, then probably other climatologists, they look at the data, they look at the analysis and the paper, and then they say, well, it's sound and it makes sense what you investigated, and then they accept or reject it. If it's accepted, then the paper gets published. If it's rejected, then you have to revise the whole thing and maybe correct some things. And what you see at the end is usually only the scientific article. So this is what is publicly available. What you don't see so much is the data or the analysis. But this is, of course, very important to understand how you made your interpretations. So if your conclusion is that the number of snow days is decreasing, you should be able to look at the data and the analysis as well.
This is something that I already would put on my paper?
Exactly. This is usually not available, or very often not available. All you see is the article, because this is what counts in science. The paper is perceived as the most important scientific output, and open science is about shifting the focus from the paper to the other materials, to the data, to the analysis. And increasingly, open science is also not only about this technical stuff, but also about societal issues. So citizen science, for example, talking to people, scientific communication is very important. And this is also part of open science.
Okay, and how do we do that here at ITC?
At ITC, this is basically my task. So I'm the open science officer at ITC, and I help researchers at ITC to make the transition towards open science. So maybe they don't know how they can make the data publicly available. Maybe they don't know how to publish the analysis. And then they can contact me, and I help them. And I also proactively develop some kind of software to help researchers adhere to open science principles.
Okay, but what is the reward for the researcher? Because in principle, the publication would be the reward, right?
Yes, so nowadays the publication is the main reward, but this is slowly changing. So we have some kind of an extrinsic motivation to do open science because many funders, for example, many research funders, increasingly ask how you want to adhere to open science principles. So you only get money if you can explain how you want to apply open science principles in your project. Otherwise, you will not get the money. And also when it comes to evaluation. So if you want to apply for a job in science, if you want to get promotion or tenure, then open science will in the future also play a more important role than it plays today.
Okay, and I can also imagine that there is some kind of larger impact towards science in general.
Yes, and this brings me actually to the intrinsic motivation. So we have some goals at ITC. So for example, the Sustainable Development Goals. It's about fighting poverty, climate change and all that stuff. And we can fight against that better if we can advance science and make the scientific progress faster. And this is in line with open science because you share the materials, you collaborate with others, and together we have joined forces at the end, and then it's easier to fight these challenges.
And in the geodomain, are we the only ones doing that? How is it working?
No. So in the geodomain, it's very important because we investigate a lot in the context of climate change, for example. But it's also relevant in other research areas. So we have seen during the corona crisis, for example, that sharing research data was very important to understand the virus and also to share results early in the process. And it's also a matter in biology, medicine, and fortunately it's also getting better in the geosciences.
Okay, and for me it looks like in many cases this will be a lot of data, a lot of terabytes or petabytes of data. And how do we manage this amount of data?
For that we still have to find solutions. So big data and open science is an issue because it's quite difficult to share such large data sets. But for these data sets it's even more important because collecting data and generating data and at the end generating scientific findings is very expensive. And we pay a lot for that. And then it's even more important that such kind of data is also available for others. So they can build up on that and they can reuse it. Because if everyone has to start from scratch, then we will not reach that much.
Machine learning and artificial intelligence usually is a topic that raises a lot of issues. How can open data help?
Machine learning is also an issue that still needs some investigation in open science because open science is a lot about understanding also the analysis in the source code, for example. And machine learning is per se actually not that understandable because it's somehow closed. And even if you would open up the code, it's quite difficult to understand why something happened in machine learning. It's even more important to open the data because this is how, for example, machine learning algorithms learn stuff. So it should be transparently accessible how these algorithms learned at the end. And this is very important through open data.
Okay, and I've been hearing a lot about during this talking to other staff members about the use of cloud computing. How does that affect as well sharing of data?
This affects it a lot because all the materials ideally are in the cloud somewhere. So if you're thinking of data repositories where you would publish open data, this is all cloud-based at the end. Also the analysis is also in the cloud at the end. And all the solutions that support open science principles are basically cloud-based. So you go to a website and this is where you can access the data, upload the data, or even look at the analysis and redo the analysis.
Nice. And how do you see the future of open data?
I think there are basically two steps in open data. So one step is first of all to make open data available. And this is where we are currently. So it's not common to publish open data, but this is the first goal. The second step would be to make data reusable. Because if data is accessible, it doesn't mean that you can also understand the data and that you can also reuse it, because it can be so complex that you just don't understand what it is about. And then you are maybe prone to start collecting data from scratch because you don't understand it, and then what can you do? Then you collect data by yourself. But making it understandable and reusable, I think this is even more complicated than making it available.
And are we going into that direction?
This is at least my goal at ITC. So I would like not only to make researchers aware of open science principles and push them to publishing open data, but it's also about creating innovative technologies, how others can reuse the data or the analysis.
Do you want to be a GeoHero as well? Then take the first step and click the subscribe button and then the bell button to always be the first to know when one of our GeoHeroes posts a new video.